Dear friends, welcome to this electrical engineering knowledge sharing channel AMP Power System. We are discussing about the switchgear control schematics, and under the control schematics we are discussing about the cable block diagram, out of which we have already completed power and control cable block diagram. Today we are going to discuss the final last one, that is that auxiliary power and the control power cable block diagram. These cables actually powering the switch gear for the various auxiliary AC power as well as DC control power. We have already discussed why this AC auxiliary power and the DC control power is required. We have seen that switch gear has various power devices as well as control devices, instrumentation devices, protection relays. All of these devices needs auxiliary power to operate. Out of these power devices like a circuit breakers, isolators, these need a slightly higher voltage power supply because these devices need a good amount of power because there is actuators, there is a DC motors. That's why those power devices, auxiliary power or control power you can say, we provide through a 120 volt DC supply. Now this 120 volt DC supply is actually used for the circuit breaker control, like a closing operation, tripping or opening operation, then various auxiliary relay operation. All these circuits we need the auxiliary supply, which is supplied at a 120 volt DC because closing operation is done through a solenoid and the actuator spring charging mechanism is operating through a DC motors. So those needs a higher power supply, higher amount of power, so higher VA capacity. That's why we generally use 120 volt DC supply. So there will be 120 volt DC supply. In addition to this, there is a protection relays, there is a transducers, there is the annunciator on the switch gear that also needs a auxiliary power supply. That control power we supply from the 48 volt DC supply or 24 volt DC supply. In this discussion, we are considering 48 volt DC supply. That means from the control control power supply point of view, we are considering this 11 kV switch gear has a two control supply. One control supply for 120 volt DC, which is mainly will be used for circuit breaker closing schematics, closing scheme, closing power, circuit breaker opening power or tripping power, and at the same time various auxiliary relays power supply, because all the auxiliaries has a coil which need to be energized. That coil supply also we are considering that under 120 volt DC supply. And the other control supply, which is a 48 volt DC or 24 volt DC, under our discussion 48 volt DC will be used for the mainly for the protection relays control supply, various transducers control supply. Then we have a annunciator, that control supply. In addition to this, if there is any other instrument or instrument devices which need a control supply, some auxiliary relays maybe need 48 volt DC supply. 48 volt, if there is a DC relay, it needs 48 volt DC supply. That relay also is considered under this 48 volt DC. These are the two mainly is DC supply for the switch gear. In addition to this, we have seen that this 11 kV switch gear, in each panel there are certain devices which need the AC power. Like there is in each power in the control section of the circuit breaker, you have already discussed switch gear has a two part. One is a power section, another is a control section. Power section is containing mainly the circuit breakers and the isolators, CT, PT, all this thing is remaining in the power section, which is generally, if it is a full height panel, it will bottom part of the panel, and the top part of the panel, which is mainly the control and protection section, where the control relays, protection devices, various switches, auxiliary relays, all these things are mounted. Now this control section needs a indication light to look inside the panel, because inside the panel we need some lights. So this normal switch gear room light may not be adequate to look inside the panel. That's why normally inside the panel we put some lamp or some small tube lights which need the power supply. That is normally AC power supply. In addition to this, nowadays all the panels are supplied with a digital intelligent relay or numerical relay, you can say. Those relays needs an auxiliary power supply because the relay is not required power supply, But this power supply, when somebody comes with a laptop to download the file or upload the file to the relay, then this laptop to be operated. So this laptop maybe needs some time power supply, or some other gadget which need to check, or due to testing purpose need some test equipment, need a 122 to 240 volt AC power supply. For that purpose, we put a plug socket inside the switch gear. So that plug socket also needs a 240 volt AC power supply. In addition to this, inside the panel there is a space heater, because when the panel is not running, or some during winter time when the condensation might be there, or heavy due to summer time, if the outside temperature is very high, there is a chance of condensation. In that case, both in the power section as well as in the control section, that's why we put some space heater inside the panel. That also needs a power supply. In addition, that power supply also provide from the 240 volt AC supply. In addition to this, we have already discussed during our control power cable block diagram that various AC motors and the generators, all the motors are all the rotating machine on their winding, to keep their winding heated when the equipment is not running. There is a space heater inside the generator enclosure as well as motor enclosure, and this space heater would be on when the motor or the generator is not running. But that space heater power is coming from the switchgear panel, from the respective panel, through the breaker NC contact. That the breaker, when the breaker is off, when the circuit breaker is off of that particular equipment feeder, then the main power supply is not going. At that time, we need to supply the space heater of that particular equipment inside the enclosure. For that also, that space heater power for that rotating equipment, either generator or motor, is coming from the switchgear panel. For that also, we need a 240 volt AC supply. These are the mainly used for the various auxiliary power. So to supply this power, we use some special logic over here. We generally do not give one supply to panel, because this is a very critical. If the DC power is off, immediately circuit breaker will not able to operate. Suppose 120 volt DC power, which is used for the electrical control, that is circuit breaker operation, closing, opening, various auxiliary relays, if that 120 volt DC supply suddenly fail, then entire operation will be stopped. And moreover, if the breaker is already closed, then it may fail to trip. It will not trip. That will be very dangerous. If during power supply, control power supply failure, if there is an abnormal condition in this electrical circuit, main power circuit, then circuit breaker need to trip. If the circuit breaker fail to trip due to this control supply failure, then there will be a danger for the power system. That's why this DC power, either it is 120 volt DC or 48 volt DC, we always to power supply to this equipment, to this switch gear. So that two power supply is coming from the two different DC UPS system. You know, the battery DC supply is coming in the plant through the DC UPS, or call you battery charger. There is a backup battery and there is a charger. That charger taking the AC supply from the system, converting to DC supply, and that DC supply also cascaded with this, that is also backup by the battery, and from that the DC supply is coming. So their total DC is coming to a DC distribution board. From the DC distribution board, various feeders are going to the various equipment. So our connection point with the switch gear for the DC supply to the DC DB. But this DC DB I have drawn here 120 volt 2 DC DB. For simplicity, I have drawn the circuit in advance. We have drawn two DC DB 120 volt voltage, two DC DB 1 and DC DB 2. And for 48 volt DC, we have also drawn two DC DB 3 and DC DB 4. These are the 48 volt DC DB 2 numbers, and DC DB 120 volt DC supply, that is a 2 number DC DB. Similarly, for the AC supply, also we have a ACDB 1 and ACDB 2. ACDB 1 is a 240 volt, one we take from the normal. This is, I am coming to this is also two dual supply is arrangement over here. These are the power. That means when we look into the auxiliary and control power supply, there are total 6 cables is coming to the switch gear. 2 cable is coming from the DCDB 1 and DCDB 2 for 120 volt. 2 this is a 48 volt DC 48 volt supply. 2 DCDB 2 cables are coming from DCDB 3 and DCDB 4, and 2 cables are coming from ACDB 1 and ACDB 2 cater for 240 volt auxiliary power. These are the arrangement. Now, we have said that why the two DCDB is there from the critical operation point, considering the criticality of this operation, we always take two feeder, one from two different DCDB. This DCDB we are backup by one UPS system. If we draw, there is a UPS, DC UPS in back of this for each DCDB. This, if this is the DCDB is the final output, but this DCDB is not from where it is getting power. There is a UPS system here, that is DC UPS. There AC supply is there, output of DC, and this is backup with a battery. Okay, so like this. So this is our battery, and this is the DC UPS, which is supplied by AC power. This AC power is converted to DC power. This is the DC power. This DC power also, that is backup with the battery, and this is catering to the DCDB. This is the arrangement for the DCDB. So this DCDB, from this DCDB, this cable is coming. Now this is the, so there are two cable. This cable, as DC is a two positive and negative, or positive to ground, whatever if the neutral is, if the negative is grounded, then positive to ground, or it is a positive to negative. But normally we lay a 3-core cable. Okay, and this cable need to be sized very precisely, because the DC, it is not a very high voltage, 120 volt. If the voltage is dropped less than 5%, more than 5%, then the various operation may be disturbed. That's why when we are sizing this cable to 50 square millimeter cable, we look into the voltage drop calculation very minutely. We try to calculate this voltage drop should not be more than 3%. 2.5% is the normal. We calculate within 2.5%. With that voltage drop, it should not be more than 2.5%. With that voltage drop, we size the cable, and then that cable size we put. I have considered 50 square millimeter 3-core, or if you want to use 2-core, you can use a 2-core cable. That one number 3-core or 2-core 50 square millimeter XLP cable. It is a 600 volt grade cable that we are using for this DCDB. That is, the length is a 300 meter, both the DCDB 1 and DCDB 2. DCDB 1 is a 300 meter, DCDB 1 is a 250 meter, DCDB 2 is a 300 meter. Both the cable is identical size, and this cable laid on the cable tray. That is the symbol of the cable tray, and there is a cable number. The cable number we will put in the same way as we discussed in the case of power cable block diagram. How the cable number will be given? Suppose if we consider this cable number, so this cable number, this cable is coming from where? From the DCDB. So we can write down DCDB 2. It is coming from DCDB 2 colon. Where it is coming to SG1, switchgear 1 colon. Suppose this is auxiliary power cable, we can give the tag P1. So this will be the cable number. So from this immediately we can make out this cable is coming from DCDB 2 as a source. Where it is going to switchgear 1. This is the 11 kV switchgear, which tag is switchgear 1, and the cable number is P1. Similarly, if we want to tag this cable, how we will do that? Similarly, here we will give DCDB 1 colon. Where it is coming, it is SG1. SG1 colon, we also give it is another cable P1, because this will make the identification. Though the cable number is same, but this will make the difference. This P1 cable, we can understand it is coming from DCDB 1, and this P1 is cable coming DCDB 2. If you want to avoid confusion, you can give another number, that is no issue. You can give a P2 if you want. So this way we put the cable tag, and this is the size. We have sized the calculation accordingly, we have put it, and this is showing the laying method. So these are the two, DCDB 1 and DCDB 2. Similarly, there is a 48 volt. Now this DCDB, this power is coming to the switchgear in one of, suppose this switchgear has a 25 panels. Okay, now this power supply is coming to a specific panel. Suppose panel number 10 or 11. Suppose this is panel number 10, where two cables are coming. Now here, now this both the cable is not connected. Now there is a changeover scheme inside the panel. That means there are two cables, and these two power supply, one power supply coming from DCDB 1, another power supply coming from DCDB 2. This two power supply independently coming to the panel number. Suppose this is a switchgear panel number 11. Okay, in this panel, inside the panel there is a small relay scheme. That relay scheme, this two supply is coming to a panel. Suppose this is the panel coming, and then there is a changeover scheme over here. That changeover scheme, it has auto changeover scheme. That auto changeover scheme will ensure that at a time only one supply is coming, not both the supply is connected to the panel, but only one supply, one feeder, one cable is supplying power to the panel and the other feeder is off, or it could happen that both are hot standby, that also both are same voltage, so both could be hot standby. Okay, so and if any one of the cable fails, suppose this DC-DC power supply for any reason, UPS, battery or the cable failed, in that case this power supply will not go there, immediately this supply will take the panel supply. So there is an auto changeover scheme inside the panel that I will discuss in the next video. We'll discuss how the DC supply auto changeover taking place inside the panel through the relay scheme. That we'll discuss in the next video. This is the video 72. In the video 73, we'll discuss the auto changeover scheme for the DC supply. Okay. So this way actually this power supply is coming from these two DC-DB. Similarly, 48 volt DC, this is more critical because this voltage is very less. In that case, this cable to be calculated very precisely based on the various load. Once we calculate the how much VA load for this 48 volt DC for the various panel, because this supply will cater, suppose this switchgear has a 25 panels, so this supply will cater for all the 25 panels power requirement. So we have to calculate for each panel how much 48 volt VA requirement, and then we'll sum up all the 25 panels, and based on that we will calculate the total kVA requirement. Based on this total kVA requirement, we can calculate how much the full load current. That full load current, based on the full load current and the distance and voltage drop will be maximum 2.5%. It should be less than 2.5%. Based on that, we will calculate. You understand, 2.5% of 48 volt means it will be about less than, because 10% is 4.8 volt. Okay, 5% is 2.4 volt. 5%, 2.5% means 1.4 volt. That means this voltage will be about 46.64 volt maximum, not minimum. Less than that it cannot work. The system will not work. So very precisely based on the kVA requirement, we will calculate that DC-DB size, this cable size, and that 2 numbers cable. I have considered 50 square millimeter cable to be laid between switchgear this panel as well as this panel, and that cable is a 50 square millimeter. This is also 50 square millimeter cable. This length is 200 meter, this length is 150 meter we have considered. These are the two DC-DB cables. Same way this cable we have shown, this cable laid on the cable tray. This cable, if we give the tag of this cable, how will give the tag? DC-DB 3 colon is going to HG1. Suppose this cable number is given 1. We can give P1, that is the cable number. So similarly, this cable number also we can give it, and the length is mentioned over there. So these are the 4 DC cable is laid. Okay. Now, in addition to this, as we have discussed, that there is a AC power supply also required. I am deleting this part. AC power supply also required for the indication light. For the if there is indication light of AC indication light is there, that light is required power supply. There is a inside the panel, there is incandescent lamp or there is tube light to look into the control section of the panel. There is a spacer inside the switchgear control section as well as power section. Then there is a AC power requirement for the various spacer located in the field, either in the generator enclosure or the motor enclosure. For supplying power to that also we need the AC power. So there is, we have considered 2 AC power over here, and this 2 AC power is not coming from the same switchboard. If you have enough UPS capacity, you can take this AC-DB. This AC-DB similarly we can take from the normal power supply, or we can take from the UPS power supply. I have considered one power supply is a normal. This is from the normal switchboard. The normal switchboard tag is AC-DB2, that is normal, which is coming from the main power transformer, and this AC-DB one power supply is coming from UPS power supply, uninterrupted power supply. As like this, it is a AC UPS. You know how AC UPS is working. There is a UPS means there is a AC power supply battery, and then this is a supply is coming from the normal, from the switchboard here. This is a converter converting to DC. Then there is a battery connection over here. Okay, there is a battery connection is connected over here. Then it is a DC supply is coming over here. Then this DC is converted to again AC by a thyristor. This is a DC is coming over here, and AC is output. This AC is coming to this AC-DB1. That is the called UPS supply. So if any case this power supply fail, this main power supply fail, then immediately this battery will give the power supply to this AC converter, which is converting DC to AC, and that AC will get the power supply to the switch gear. So this is one is a normal, and this is a UPS supply. UPS supply. So we are giving two supply. This supply coming to the switchboard. Okay. Now here is the problem. This is the AC supply, so they have a frequency. So we cannot connect these two AC supply like a hot standby. We cannot make it. We have to make a changeover scheme inside in such a way so that at one time only one power supply is there. If that power supply fail, then immediately second power supply will come in. Okay. So these both supplies coming to the switchboard. But suppose this panel number 11 is AC supply also coming in there. And from that 11 kV, 11 panel number 11, we have to make a auto changeover scheme. But that auto changeover scheme will be different from the DC auto changeover scheme. In the case of DC, we can connect both the power supply because there is no idea of synchronization. But in the case of AC power supply, we cannot connect two power supply coming from two different sources. You know, because there is a AC supply like this. So the phase sequence, phase and position clock, the phase frequency and phase, that should be same. Otherwise, there will be a over voltage or under voltage. To avoid this thing, both the supply is coming over there and it is given as a connected, but through the changeover scheme, we will take only one supply at a time and other supply will be off. When that particular, when one of the supply, normally one of the supply is off, other is running. The moment that supply fail, immediately this will be transfer will take place. But the transfer will make it very fast because as we seen, this is not for the control power, it is for the space heater auxiliary power for that type of purpose. So intermittent, even for some microsecond power supply is off, that does not cause a major difference. That's why we make a auto changeover, but that auto changeover will be not through the hot standby, it will be auto changeover with one normal, one standby. In this way, these two supply will work. So this power supply is, as it is a 240 volt and this cable size is not very high required, we have considered here 3 core because 3 core is one phase neutral and one is arc. 3 core 25 square millimeter cable, and the length we have considered 200 meter, and it is also laid on the cable tray, and the cable tag we can give in the same way. Suppose in this case, if we want to give the cable tag of this cable, what will be the cable tag? It is going from AC-DB1, then we give a colon of SG1, then we give a copper cable number is P1 or P2, P3, whatever you can give it. So this will be the cable number. So this way we can make this scheme. Okay. Now, in addition to this, what we discuss that this auto changeover scheme we can make a separate video. Otherwise, this video will be very long. So through that video, we will show how the auto changeover scheme works for the DC as well as AC. Okay. With this, I am closing this video for today. And in the next video, we will discuss about the control power supply auto changeover. And thank you very much for all of you to continue with me. And I am hoping that we will be continuing the same way. And please share this video with your friends and other colleagues so that all can be, if there is any benefit from anyone, that will be my pleasure. Thank you very much indeed. Thank you.